Okay, welcome to section 3. In this section, we're going to look at finding the derivative of an inverse function. So I'm going to start by showing you how to do this just kind of intuitively, and then I'm going to show you problems where the intuition doesn't exactly work. Okay? So our objective for today is to find the inverse of a function and then find the derivative of the inverse of the function. Before we do this, let's just recall some information from math. I'm not sure where you learned this, math 3, math 2. But remember that if we can compose two functions and get x, then they are inverses of each other. You also need to be familiar with the notation for inverse, which is simply f to the negative 1. That means inverse, and you just need to be familiar with that notation. So if you recall from previous courses, the inverse is simply a reflection over the y equals x line. In order for a function to have an inverse, the function has to be one-to-one, meaning it is strictly monotonic. Either it's always increasing or always decreasing over its domain. If that's not the case, then we can restrict the domain in order for it to have an inverse, in order for the function to have the inverse. So that was all just prerequisite knowledge. Now we're going to the calculus of it. Okay, so if I wanted to find the derivative of this inverse at 4, intuitively what I would do is I would find the inverse of the function and then take the direct derivative. So if you recall from previous courses, to find the inverse of a function, we exchange x and y and solve for the new y. Notice also that I restricted the domain because this has a vertex at negative 4/3. So in order for it to have an inverse, I had to restrict its domain to x has to be greater than 4/3. Then it's always increasing from negative 4/3 to infinity. It's increasing, and therefore it has an inverse. So to find the inverse, I am going to exchange x and y. So I get x is equal to 3y plus 4 squared. Solving for y, I take the square root of both sides. Notice I don't bother with plus or minus because of my restriction. And if I did plus or minus, it would no longer be a function. So solving for y, I get the square root of x minus 4 over 3 is equal to y, which is the inverse of that function. So to find the derivative, I just take the derivative of this. So the derivative of this inverse would be negative 4/3 is a constant. So the derivative of this, I bring out the 1/3, take the derivative square root of x, which is 1 over 2 square root of x, which is 1/6 square root of x. And if I evaluate that at 4, I get 1 over 6 times the square root of 4, I get 1/12. And that's my answer. Ta-da! I did all of that in a little space. I have all this over here. I don't know why I did that. But that's my answer. Now, every function is not like that. I cannot always find the inverse of a function. So if I can't find the inverse of a function, I'm going to find its derivative, I'm going to use this formula. Now, the thing to remember from this formula is that g prime of x is the inverse of f. So I could write this as excuse me. Okay? Just recalling because I said here that g is the inverse of f. So if it's the inverse of f, I could also write it this way. So what does this mean? This means that the derivative of the inverse of a function at a point is the reciprocal of the derivative of the function at the corresponding point. Now we have to talk about this. This seems confusing, but hold on, I'm going to get you through it. It's not that bad. So what we want to notice, unlike the problem that I did before, I cannot find the inverse of this. Okay, so if I do x is equal to 1/4 y cubed plus y minus 1, I don't have the mathematical skills to find the inverse. So then I have to use the formula that I just gave you. So the first thing is to notice, we have to recall inverse of a function simply means to exchange x and y. So let's say for instance, if I had a function and it had a point 1, 3, then the inverse of that function would have a point at 3, 1. Do you agree with that? Do you understand that? Because I'm simply exchanging the x and the y. So if I want to find the derivative of this inverse, and since I can't find the inverse algebraically, I'm going to have to do it by using just a point on the graph. So my first step is to set 3 equal to f of x. Now, I cannot solve this algebraically. I'm going to have to use a calculator to solve this. I guess I could, excuse me, I guess I could, but it's going to be easier just for me to use the calculator to solve it. So give me a second. I'm going to put 1/4 x cubed in my calculator plus x, sorry. You should be doing this on your calculator as well, solving for this, and hopefully we'll come up with the same answer if I can put it in my calculator right. And I want that to equal to 3. And I get that x is equal to 2. So x is equal to 2. So that means that in the original function, in the inverse of the function, I would have a point 2, 3. The inverse of that would have a point 2, 3. Okay? Hopefully that makes sense. So now what I need to do is I'm going to use this point of 2 in the formula that I just gave you. So to find the inverse of this, I have to start by finding the derivative of the original function. So I'm just going to go here to save space. The derivative of this function is 3/4 x squared plus 1. So according to the definition I just gave you, this will be 1 over the derivative of that function evaluated at my new x value, which is 2. Which is going to give me 1/4. Okay? Let's do the next one. Okay, so once again, this is my x value. And I have to make my x value my y value when I do the inverse. So I set -11 to 1 over 27. Okay, so once again, we're going to use our handy-dandy calculators to calculate that. I know the final answer. I don't know this answer, so I'm going to have to use the calculator. 1 divided by 27, parenthesis, x raised to the 5th power plus 2x raised to the 3rd power, and I want that to equal to -11. I got to change my window. And I'm going to graph that. Excuse me, I don't know what's wrong with my throat. And I get x, my new y value, my new x value is -3. So I get x is equal to -3. So that means that on the inverse, I have a point -3, 11. -11. Okay? So to find the derivative of the inverse, I'm going to do 1 over the derivative of this function, which would be, so f prime of x is equal to 1 over 27 times 5x to the 4th plus 6x squared, evaluated at -3. So that's 1 over 27, 5 times -3 to the 4th plus 6 times -3 squared. And I think that gives you 1 over 17. That's the derivative of the inverse. So, I think you could do that problem, but I want to show you something on this problem. What I want you to see, let's see if I can move this. Yeah, I can move it a little bit. Look how big. What I want you to see is that on this one, I can use both methods. I could find the inverse of this. So I'm going to do that. I'm going to use method 1 where I actually find the inverse. The problem with this is just that it doesn't work all the time, but it works on this one, so let's do that. So we get x is equal to the square root of y minus 4. So then y is equal to x squared plus 4. I squared both sides and then I added 4. So then the derivative, so now this is the inverse. Let me use correct notation. This is the inverse of this function. And so now the derivative of that inverse is 2x. And then evaluating the inverse of this, the derivative of the inverse at 2, I get 4. Straightforward. Now let's use the second method that we just learned. And what I'm just showing you is that you get the same answer. So to do the second method, I have to set x minus 4 equal to 2. To solve for x, I square both sides. I get x is equal to 8. So that means that there, on the inverse, there's a point 8.2. So what I'm going to do now is take the derivative of this, which is 1 over 2 square root of x minus 4, and I'm going to find the inverse of the derivative of the inverse, by taking 1 over 1 to the square root of my new x is 8 minus 4, which gives me 1 over 1, 2 times 4, which is 4. 8 minus 4 is 4. The square root of that is 2 times 2, so that's 1/4. And of course, 1 over 1/4 is 4. So you see I get the same answer both ways. Okay? Now, it gets a little bit more complicated than that, but I want you to try a few of these. For homework, I think your homework was only this. You don't have to do all of this. It's just this, and it's all of them, not just the odd. Okay? All righty. Have a great day.